What you're looking at is not just a helmet, but for one baby, this device means the difference between lifelong facial asymmetry and a normal head shape. I'm called Dr. Atish Shah. I have a dual background in medicine and engineering, and I'm the founder of Rover Labs. And today I'm going to take you through the tech that I use to make an impact in the community and hope that it inspires you. So 85% of people living with disabilities in Africa don't have access to assistive devices. And this is because of high costs, insufficient local production, and substandard customization. Let me take you through my journey, what I was, and the process in which I became to be what I'm doing right now. So when I was in O-levels, I didn't know what I wanted to do, right? Did I want to be a doctor? Did I want to be an engineer? And so I took 4 subjects. So I took math, physics, chemistry, and biology. And I wouldn't want to, lie to you, right? We all have our flaws, and I was not the most hardworking person in the school, but I was good, fairly good, because I got a scholarship here. And so we had a bunch of friends. We would work hard. I mean, we would work, but not as hard. And we were like, we are not the most ideal of students, right? So we would bunk school actually. And I don't know if Mr. Abdul Wahid is still there, but he used to catch us, and some of us also got suspended, right? But we did well. We went into the university, right? So I went into one of the good or the best universities in the country, Muimbili, which is just next door. Some of my friends went into engineering, but that's history. So once I finished med school, right, I encountered an upper limb amputee. So an amputee is a person who doesn't have hands. And I was thinking to myself, what can we do to help this person, right? What can we do locally to help this person? And being a fan of movies, right, sci-fi movies, so you see the Terminator, you see Iron Man, right, and you see all those robotic hands, and you see, okay, I mean, how hard would it be to make something like this? So I gathered up a team of engineers, and soon I realized that I need to go study engineering if I have to make this, because there was a lot of miscommunication between us. Some of them are lacking skills. And so I said to myself, okay, I'll go study this, right? And how does a medical doctor go into an engineering school? So it's difficult, right? So I was trying to find programs for masters in biomedical engineering, and none of the programs would let in someone who does not have a background in engineering. And I had to study, right? So some of the programs told me that I have to give an exam. So I had to study math and physics for an year. So I took a break from working in the hospital. I studied math and physics, and I got in one of the universities in Scotland, in Glasgow, by a whisker, right? So if the pass mark is 50, we got a 51, and we got in, right? And after I was done with engineering, we started building, a hand, right? It's nothing like the Terminator hand, but it works. Right, so we started building a 3D printed hand. We built our own circuits, we built our own code, and then as I gathered a team of engineers, a bunch of engineers, I would delegate work rather than trying to know, okay, this is what we have to do by listening to other people. I would be delegating work, right? And we made this, and it was working on an amputee. Which a kid amputee, which we got at Muimbili. Now coming to the technology, right? A lot of you spend time scrolling on Instagram, doing Netflix, right? Which is a good thing to do. I think it's good for your mental health, right? I cannot be someone who is morally superior, because I was also bunking classes, but anyway. I think that you should spend some of the time in this, because this is not the future, this is now. And you go to YouTube, you see how things work, so that when you go to the university, you know what questions to ask to your professor. Okay, this is how some of the technologies are applied, right? And I'll show you some of the things that we do, right? Or I'll explain to you some of the technologies that I apply in my work, in my business. So let's say we are making an orthotic device, right? Let's say we are making this helmet. How do we make a customized helmet? So you see there in the picture, there is an iPad, right? So any one of you has an iPad or an iPhone already has a 3D scanner. So there is actually an app to do this, right? So we 3D scan the limb of interest. In this case, we are making a splint for someone having arthritis. So we scan the limb. Once we scan the limb, we have a digital file. So let's say if you are in, I don't know, in Monza or Morogoro, you don't really have to come to us. You get this scan, you send us a file, right? Once we get the file, we model it in a software. When I say we model it, we design it. And we design it using generative AI. So guys who are interested in AI, doing a little bit of physics, you can research in your own time what's generative AI. With minimal human input, actually, right? So we don't really have to do a lot of things, right? The AI does quite a bit, right? 80 or 90% of the stuff is covered with AI. It's designed by AI. Once that's done, we 3D print the device, we post-process it, so we put in some codes, and we ship it back to you wherever you are from. So you don't really have to come in our offices or set foot in our offices to get something made. Some of the other devices we make, the same process, the same technology behind it. We make helmets, we make splints, we make braces, and braces I'll come to you in a minute. And it's similar, it's highly customized, using the same technology that you have in your pocket. Apart from scrolling on Instagram, you can look at these apps, right? 3D scanning apps, and you can start tinkering with it. And once you're done with university, you actually have a vision. Okay, this is what I want to do, or this is what I'm going to do. Now coming back to AI, how do we actually use AI, and in what cases do I use AI to make or to innovate devices? So if you look at the picture on the left hand side of the screen, there are two objects. One is a cream colored object, and the other one near it is bluish green colored object. These are both hinges. Right? The one that is cream colored is human made. So it's made by us using the software. Basically, think of it as a drawing software. It's a CAD software. The other one is made using AI. Now if you look at the differences, the one that is green colored has lesser mass. When I say lesser mass, is quite light. It's light, but it's strong, probably stronger than the first one, and it's made using AI. I won't go into the details, but yeah, you can research at your own time how this is done. You just type generative AI in YouTube, and you'll start getting a bunch of videos. Coming to the next picture, I know a lot of you are doing math, and you have sines and cosines, right? So this basically is an EMG signal, and it's a high frequency sine wave, right? And there is a pattern here, and this comes back to the bionic hand that I showed you we're making, right? So for the bionic hand, we need to actually see what movements the hand is making from your brain signals, right? Or your muscle signals. And these pattern, it's a bunch of sine waves, high frequency sine waves, and there's a pattern for every muscle, right? So you want to open your hand, you want to close your hand, there are different patterns. And we actually use AI to detect these patterns, right? So you are not making the decision, it's the AI that is in the chip, you upload it in the chip that makes the decisions and makes the the hand work according to the way you want it to work. Now I told you that I have a dual background in medicine and engineering, so I was talking a little bit about engineering, right? AI and CAD. Now let's come back to medicine. So what you see there is a brace, right? It's a spinal brace for people having a curved spine or a spinal deformity or hunchbacks, and we actually correct that, or we can correct that using orthotic devices, right? So these braces. And how does medicine come into all this, right? So we take an X-ray. I'm sure all of you know what an X-ray is. Probably you have taken it out, or you've seen it on a relative, or if you have not seen it both, you've probably seen it on a movie. And then we take these angles, right? So people doing math, right? These are two parallel lines intersecting, right? And that intersection, and this is trigonometry, it's called the Cobb's angle. We calculate that angle, right? And then using this angle, we design the whole thing, and we know exactly what pressures to put in. So coming back to to medicine or biology, right? How the whole physics, engineering, biology interweaves to make these devices. And then lastly, once we design the whole thing or the whole device, this brace, we 3D print it, right? So I'm sure you guys know what printing is, but we use it in a regular basis. And what a 3D printer allows us to do is gives us the versatility to choose the material. So you want something like this. You're wearing 24 hours a day to be firm, to be comfortable, but also be strong, right? And we have a wealth of materials. We can make it out of carbon fiber, polypropylene, foam. And 3D printing actually allows us to use the material that is the most comfortable, for a patient or for a human being. So I hope this inspires you. This is the technology now. This is not the future. I'm doing it. We work with a bunch of universities to do this, and I think it would be of value for you guys to actually just do some research and see how how the whole thing works and how it's done, so that once you're doing your higher studies, you actually have a vision. Unlike me, I didn't know what to do until a little late or a little later, but that's fine. But if you know what you're going to do a little earlier, it saves you a whole bunch of time, right? You're not wasting time doing this and that. It will really help you narrow down your career choices. So I hope you take the roads less traveled, and I hope this inspires you to do good in life. Thank you.